Hello, everyone. I hope you hear me well, and I hope you see my slides well as well. Okay, so let me first introduce myself. My name is Jelena Jovanovic, and I'm coming from University of Belgrade in Belgrade, Serbia, and this is where I'm calling in from today. And the work that I'm going to present you today is the work that I have done together with Shane, Srećko, and George. I suppose there is no need to introduce them individually, you all know them. And well, I'll start with the talk. It's organized just as usual. First say something about the motivation for our work. Then we'll introduce objectives and research questions. Then we'll give an overview of the study method and the results. And finally, we'll wrap up with a summary of our findings and some of the implications. Okay, regarding the motivation, well, I suppose that we are all aware, either from our personal teaching experience or from literature or both, that teachers often have limited insight into the learning techniques and strategies of their students, especially when teaching online, since in those online learning settings, for example, those visual cues that you're so used to when teaching face-to-face are either limited or not available at all. Also, I suppose that as members of learning analytics community, we are aware in the last couple of years, there have been several proposals, several, let's say, proposed approaches for identifying study techniques and strategies from learning trace data. And in fact, the use of learning analytics to identify techniques and strategies proved to be a viable alternative to student self-reports. However, there are still some open issues and challenges. One of them that we have identified is limited explanatory power of the detected behavioral patterns. Why I say behavioral patterns? Because what we are able to identify from trace data is are behavioral patterns or latent constructs, and that we suppose or try to interpret as, let's say, learning techniques and strategies. And why I say it's limited explanatory power? Well, it's primarily related to the kinds of features that are often used to identify techniques and strategies. And they are in large majority of cases restricted to one aspect of learning behavior, typically overall learning activity or sequences of learning actions or something like that. So when it comes to interpreting the identified patterns, we have, let's say, a limited amount of information to do so. Another thing that we notice is that in large majority of the proposed approaches, let's say the data from the overall course was used to identify techniques and strategies. And therefore, those strategies that are identified are available only at the end of the course. So lack of support for in-course interventions, meaning interventions while the course is still up and running. When mentioning interventions, of course, I'm coming to the reason why do we want to identify those strategies. Of course, one reason is to better understand the learning, but the other reason is to improve the learning, or as it says, stated in the definition of learning analytics, to optimize the learning. And one way to do so, and something that we have seen, especially in the last couple of years, more and more in learning analytics, is the work towards evidence-based personalized feedback. Still, considering state-of-the-art evidence-based feedback systems, we notice that such systems tend to offer information at a low level of abstraction, such as counts of quizzes taken or number of assignments completed or things like that. And that is all well and fine, I mean, informative, but still we need additional information. And in particular, we need information at a higher level of abstraction, information about learners' overall behavior, their techniques, their strategies, and also how they adopt and change those strategies throughout the course. And why do we need that? Well, we need that in order to be able to provide feedback at the process level, so the kind of feedback that has proven to be the most useful. And with these things in mind, we have defined our objectives as follows. To establish an explanatory model of learner behavior that would allow for the detection of behavioral patterns in students' online learning activities. or what we refer to as observable strategies. And we use this term observable strategies because we want to make it clear that we are actually identifying just patterns in the behavior and not having access to learner internal states, and to make a distinction from, let's say, the construct of learning strategy as typically used in the learning science literature. Another thing, this explanatory model. Why explanatory model? Well, we want these identified behavioral patterns to be as interpretable as possible to teachers. And another thing, we also want these patterns to be available to the teachers and instructors early in the course so that they can make timely interventions. From these objectives, we derive two research questions. First, can learning trace data be used to extract a comprehensive set of behavior indicators that would allow for early in the course detection of strategies and strategies that are predictive of course grades, and also that such a comprehensive set of indicators would offer rich information about those detected behavioral patterns. And then if you are able to identify such a set of features, and if you are able to identify those observable strategies, can we then compare students, especially students from different performance groups, in terms of the way they adopt, retain, or alter those strategies throughout the course? In other words, what we refer to are strategy pathways, that is sequences of strategies the students opt for throughout the course. So how we approach these research questions? We use the data from 3 consecutive offerings of a first-year fully online course taught at one Australian university in 2018. And in total, we had 1,069 students. Actually, there were more students, but this is the number of students that we had full data for. The course was obligatory course for all online students, regardless of their major, since it was a kind of introduction to online learning. It was 10 weeks long, and it had that weekly structure, meaning that it introduced one course topic per week. The course structure and the design remained unchanged throughout these 3 offerings, so we were able to aggregate the data and do the analysis. As for the data sources, we use log data from the institution's learning management system. It's Moodle actually, so it's just regular Moodle log data. And in addition, we had access to the students' final course marks that were extracted from student information system. And of course, all data were anonymized before the analysis. So the first thing we did was to examine log data, and by doing so, we identified 44 different types of log events. Those were really low-level events like a student accessed a course, a student viewed an assignment, a student posted a message, and so on. And since they were too low-level and too varied, I mean too numerous, they were not suitable for some meaningful analysis. So what we did as the first step was to define a mapping between these low-level events and higher-level learning actions. In particular, we identified the 7 types of learning actions like learning content access, assessment, informing, orienteering actions, active and passive social interaction, planning and monitoring. So how do we define that mapping? Well, in short, we studied the data thoroughly. We also studied how other researchers did a similar thing in the report in the literature, and also relied on our previous experience with analyzing similar kind of data. Then when we have data pre-processed and turned into learning actions, we started working on the feature set or the set of behavior indicators. And to define it, we started from our objectives. And from them derived the general requirements for these behavioral indicators, such as that they should characterize learning behavior that is associated with students' performance in online course, and should serve as a source of actionable information for in-course interventions. Then from this general, we derive the specific requirements, like they should be computable in regular time intervals, they should be predictive of students' course performance early in the course, and as the course goes on, they should allow for better and better profiling of student strategies. And of course, they should be meaningful to the teachers. From these requirements and with a lot of exploration, we defined 4 kinds of behavior indicators that we computed for each student. So indicators of students' overall level of activity, their level of activity associated with different kinds of learning resources that were available to them in the learning management system. Then regularity of study indicators and indicators based on the adopted study techniques. And well, all these indicators are explained in detail in the paper. I would not have time to explain them here. I would just say a couple of words regarding these techniques. Well, we consider them as patterns in sequences of learning actions within learning sessions. In a way, so behavioral patterns at the level of learning session. And we identify them for each week of the course. And to do that, we apply the method that was proposed in a paper by Macha et al. In last year's lab paper. So it's, in short, it's about expectation maximization, soft clustering adapted to process mining tasks. And by doing that, we were able to identify in each week 4 to 5 different kinds of techniques, and we used them in order to create features that were then part of our overall feature set. With the feature set defined, we were able to proceed to the detection of strategies, which we did through clustering. And we did that for each week of the course. So we identified these observable strategies in each week of the course using cumulative data. So for example, for week K, we would use trace data from, for the first K weeks of the course. How we would do that, for example, for 1 week, we would we would represent each student as a vector of feature values based on cumulative trace data up to that point. Then we would compute cosine distances between each pair of students represented through these vectors, and then use the computed cosine distances as an input to hierarchical agglomerative clustering based on Ward's algorithm. Having identified these clusters or observable strategies and strategy groups, we compare them based on their course performance, and to do that we use just a regular statistical test like Rushkoff-Wallis followed by Mann-Whitney U-test for pairwise comparisons. And to avoid discovery, significance by chance, we applied false discovery rate correction. Sorry, for the second research question, we primarily relied on exploratory analysis to compare those strategy pathways of high and low performing student groups. When I say strategy pathways, I mean sequences of strategies, observable strategies the students adopted in consecutive course weeks. So regarding the results, as I said, we identified these observable strategies after each week of the course. And very quickly we realized that in each week, after each week, we were able to identify 4 clusters or 4 different kinds of observable strategies. And starting analyzing them, we also realized that the same kinds of strategies reappeared after each week. And they are listed here in the first column, like strategy BA being active, regular, and comprehensive, B also active and regular, but selective in terms of use of learning resources, and so on. And I actually tried to give here with this table a kind of high level, very general overview of the key characteristics of these 4 observable strategies. I don't have time to go to explain each one in detail, but I'll say, for example, just let's say strategy C, marginally active and regular, but highly selective, since they had a low overall level of activity and low regularity of study, but they were highly selective. They actually show the highest level of selectivity when it comes to the use of learning resources. Comparing these strategy groups based on their course performance, we realized that they actually statistically significantly differ for all course weeks. So what they presented here is actually a table taken from the paper itself, where we have results for the first 2 weeks and first 3 weeks, so early in the course and after all the course weeks. So statistically significant difference between each pair of these strategies throughout all the course weeks. And strategy A was consistently associated with the highest performance, whereas, for example, strategy D with the lowest level of performance. Regarding our second research question and exploratory analysis of strategy pathways, I'll say first something about the high performance tier. This is a group of students whose final score was equal or above to 75, since the scores were from 0 to 100. And what we can see from this graph is that these students primarily opted for strategies A and B. As for tactics, it's not shown here, but according to our analysis, they were primarily opting for tactics that included a variety of learning actions. And what is very specific for this group is that in each week of the course, they relied on social interaction. This is something that is really specific to this group. Also, something specific to them is that they combine a variety of tactics throughout the course weeks, which is very different from the low performance tier, as I'll mention in a few moments. Regarding how they change strategies, 66% of them changed their strategy at least once, but even when they changed, they remained active and regular. As for low performance tier, so students with a final score below or equal to 25, they primarily opted, they opted for all kinds of strategies except strategy A, so that's the only one that they almost never chose. As for tactics, it's almost always focused on assessment and learning content access, and what we noticed is that as the course progressed, the repertoire of learning tactics was narrower and narrower. About 46% of them changed their strategy at least once, and when they changed, they fluctuated between strategies B and C, whereas those that remained the same strategy, they stayed with strategy D, so the lowest one, or the C. So to wrap up, what we see as advantages of the proposed method is that it allows for the detection of strategies associated with the course performance early in the course. We saw that already in the second and third week of the course, we were able to identify strategy groups that were statistically significant difference with respect to their course performance. Also, it considers both the latest learning behavior and the overall learning behavior in the course, and in that way it allows for progressively improving student strategy profiles. It also provides information at different levels of abstraction. So we can talk at the level of overall behavioral pattern, like the overall strategy, at the level of a group of behavioral indicators, for example, indicators related to the regularity of study, and also the level of individual indicators like patterns of weekly course access. And it also covers a wide range of behavioral, patterns, behavioral features. As for implications, it has something, it can contribute towards support for student-oriented personalized feedback in a way that we can inform students about their own techniques, strategies, strategy pathways, as well as of those of successful learners in the same study context. And I emphasize here own and same study context, since it has been shown that students are more responsive and more willing to follow advice when that advice is related to the same or very similar study setting than when it's a kind of general advice for learning. But of course, there are challenges and open issues, such as what is the appropriate time for the feedback, what is the appropriate form to communicate the feedback, also how to collect information about students' internal states, so their motivation and intention, but to do that in efficient and unobtrusive way, and in a way that is applicable in a wide range of online courses, so not only in experimental settings. Also support for teacher-directed feedback, as I already mentioned, we can offer information different levels of abstraction. I can also think about, for example, teacher wants to go from high level information to high level, then drill down and get more and more information, more details, or go the other way around. But of course, there are challenges here as well. So what would be the most effective way to communicate this information? How to, let's say, implement that way of drilling down or going further up? and also to develop teachers' trust, which is very important into these analytics-based insights. And finally, and I will finish with this, so, well, considering this second research question and studying those student strategy pathways, we were considering why students change those strategies and how did they make such decisions, and are those changes arbitrary or result of self-regulation of learning. And of course, we were not able to answer these questions since we didn't have data for that. And it's not only a problem with our approach, but in general problem with, let's say, analysis that are based on log data. So what we have started doing as a way forward is looking into unobtrusive and efficient ways of capturing data about learners' intention, motivation, and affect. So how can we do that? But to do that can, in a way that can be applicable in all kinds of online learning courses. So some way of, some methods like experience sampling or something similar is something that we are looking into. Okay, thank you. That's all for me.